Hey everyone, I hope you're doing great. My name is Anupam Singh and I'm thrilled to welcome you to this video. Today we are diving into one of the most exciting and talked about topics in the tech world, machine learning. Terms like artificial intelligence, machine learning, and deep learning often come up in conversations. But do you ever wonder what exactly do they mean? How are they different? How do they impact our lives? Well, you're in the right place. I'll break down machine learning in a way that's simple, fun, and easy for anyone to understand, even if you are new to it. So let's get started. So let's begin at the top. What with artificial intelligence or AI? AI refers to the ability of machine or software application to perform tasks that typically require human intelligence. These tasks include reasoning, problem solving, language understanding, and learning from past experiences. Imagine having a robot assistant that can schedule your meetings, respond to your emails, recommend new music, or even recognize your face. That's AI in action. But what makes AI so special is that it can operate without human intervention. Once trained properly, it can think, design, and act on its own. So AI is the broader umbrella under which machine learning, deep learning, and other intelligent technologies fall. So what exactly is machine learning? Let's zoom into machine learning, which is a subset of AI. Machine learning provides us with statistical tools and algorithms to analyze data, uncover patterns, and most importantly, make predictions or decisions based on the data. Here's a simple example. Let's say you run a small bakery and you've been tracking how many cupcakes you sell each day. Over time, you realize that your sales go up on weekends and dip on Mondays. With machine learning, we can create a model that uses this data to predict how many cupcakes you'll sell next Sunday, and you can prepare accordingly. This is the power of ML. It enables businesses to forecast sales, detect fraud, personalize experiences, and even recommend products. Companies like Amazon, Netflix, and Google use it extensively behind the scenes. Now let's go one level up deeper into deep learning. Deep learning is a special type of machine learning inspired by the structure of human brain. It uses something called artificial neural networks, a system of interconnected layers that try to mimic how neurons work. Deep learning shines when we have massive amounts of unstructured data like images, videos, or audios. Think of facial recognition on your phone, voice assistants like Alexa or Siri, or even self driving cars. All these use deep learning to function. So, while machine learning might need some manual feature selection, deep learning automates this process and handles much more complexity. But it also needs much more data and computing power. Let's now break down the three primary types of machine learning. Supervised machine learning. Supervised learning is the most common type. Here, the model learns from the labeled data sets, meaning we already know the input and the expected output. Think of it like students being trained by a teacher using a textbook with all the right answers. In technical terms, the dataset has independent features, the input and the dependent feature. The target we want to predict. There are two kinds of supervised problems. First, we have regression problems. In this, the output is of continuous nature. For example, predicting house prices, temperature, salary, or stock prices. Next, we have classification statement, where the output is categorical in nature. Example, predicting whether an email is spam or not, or if a tumor is malignant or benign. Classification further splits into first one is binary classification, where the output variable has two categories, yes, no, or true or false. Second is multi-class classification, in which the dependent variable has more than two categories like dog, cat, house, etc. Next comes unsupervised machine learning. Now comes unsupervised machine learning, where we work with unlabeled data. That means we don't know the outcome and we are not trying to predict it either. Instead, the goal is to find patterns, grouping, and hidden structures in the data. For example, you run a retail store and want to segment your customers into different groups based on their purchasing behavior. You don't know how many groups exist, but unsupervised learning will help you cluster them. This is commonly used in market segmentation, anomaly detection, and recommendation systems. Now let's talk about reinforcement learning, one of the most fascinating areas. Imagine training a dog. Every time it obeys a command, you reward it with a treat. Over time, the dog learns what to do to get some treats. Reinforcement learning is just like that. The model, called an agent, interacts with an environment, performs actions, and receives reward or penalties. It's widely used in robotics, game playing AI like AlphaGo, and autonomous driving. Over time, the agents learn which action give maximum rewards and optimize their strategy. Let us now quickly explore a few mathematical building blocks that power machine learning models. Equation of a line, plane, or hyperplane. In 2D, we know the equation of a line is y equal to mx plus b. In 3D, we deal with a plane, that is z equal to ax plus by plus c. In machine learning, especially in classification problems, we move to higher dimensions, and the line or plane becomes a hyperplane. A hyperplane is a decision boundary that separates data points belonging to a different classes. Support vector machines, for example, uses hyperplane to classify data. Distance of a point for a plane. Why do we care about the distance of a point from the hyperplane? Because it helps the model determine how confident it is in making a prediction. The closer the point is to the decision boundary, the more uncertain the classification is. Finally, let's talk about two learning approaches: instance-based learning and model-based learning. In instance-based learning, it stores the training data and uses it to make predictions on new data. For example, k nearest neighbors. It's memory intensive, but it is simple. Now it's come down the times of model-based learning. It trains a model to learn the relationship between inputs and outputs. For example, linear regression, decision trees, support vector machines. They are more scalable and faster during prediction. Let us quickly recap what we've covered today. What is artificial intelligence? What is machine learning and how it's different from AI? What is deep learning and where it fits? Three main types of machine learning techniques: supervised, unsupervised, and reinforcement. Key foundational concepts: hyperplanes, distances, instance versus model-based learning. Understanding these core principles will help you build a solid base in your machine learning journey, whether you want to pursue academically, professionally, or as a side passion. Thank you so much for watching. I truly hope this video made machine learning a little less intimidating and a lot more exciting for you. If you enjoyed this content, don't forget to like, share, and subscribe for more practical tech videos. Let's connect on LinkedIn. And if you are hiring or looking to collaborate, feel free to reach out. I'd love to be part of something impactful. Drop a comment if you have any questions. Until then, keep learning, keep learning.